Good evening, everybody, and welcome to tonight's webinar on Missing Data Part 2, where we will go over the technique of multiple imputation to deal with missing data values. I'm William Bannon of Stats Whisperer. I'm telling you that up front because I don't have any slides for this presentation. So the jumping between SPSS and slides can be a little dizzying. So we're going to go over multiple imputation, which is a common and very widely accepted way to account for missing data. Excuse me. Now available in SPSS. A few years ago it was not. So it's the most common software, and now you could do a rather sophisticated method of accounting for missing data with your SPSS software, and I believe it comes standard. So in Missing Data Part 1, we went over all the foundational aspects of missing data, right? The patterns and measuring the amount, and then the last part we came to treatment. So I ended by saying you should try to use as sophisticated a method as possible, including multiple imputation. And then we ended the presentation, and so we're starting up Missing Data Part 2, where we will pick up where we left off. Now, multiple imputation is actually it sounds a little daunting, but it's not at all. You'll see that it's actually pretty simple. I was moved in this direction because when I first published, I published an early paper, and they were missing data values, and it was a multiple regression, a hierarchical multiple regression. And every time I added more variables to the regression model, the sample dropped and dropped because there was missing data values within the cases I added. And when that happens, SPSS kicks out the cases. So one of the reviewers said to me, that he sent me an article, and it's, or she, I guess. Well, I'm saying he because the person who sent the article was written by a man, so I figured they were sending their own stuff. And it was all about multiple imputation. And when I first read it, I thought to myself, gosh, this just sounds complicated. I just wish there were no such thing as missing data. Right? But that's not the world we live in, and there's almost always missing data. So we're going to go over tonight how to actually do the multiple imputation so you won't have that same reaction I did. Okay, so we're going to do it in SPSS, and because I don't have any slides, because it's a little dizzying going back and forth, I'm not only going to record the presentation so you can rewind it, but I'm also going to speak slowly and do the method slowly so you could take notes. Okay, so we have our data set here. This is, as you can see the title, a practice, right? It's a practice happiness data set. Okay, so we have 8 variables, right? So we have our ID variable, and then we have some demographics, right? So right here, we're in the data view. We have ID, gender, income, and age. And then we have a few variables concerning how do you feel, right? So it asks study participants in the last 7 days, did you feel happy? The last 7 days, did you feel good? Did you feel strong? Did you feel glad? And did you feel sad? All measured on a scale of 1 to 5, with a 5 indicating a greater presence of that construct, such as happiness or feeling good. So we also see that there are empty cells. Right? So when there are empty cells, that most often indicates missing data. Now, multiple imputation, that's a good method for estimating or accounting for missing data that's due to, say, non-response. Right? So in ID number 1 here, where happy is empty, we're assuming that's due to non-response. The person maybe didn't want to answer it or wasn't sure. So there was a non-response and it's empty. But as we said with SPSS, an empty cell will delete the case from analysis. So we need to find a way to estimate what that missing value would be. So multiple imputation is appropriate for non-response. And then other developments, such as if you do a longitudinal study, where you have dropout, right? So if someone's present at time point 1, then they're not present at time point 2, right? But you want to do an intent to treat analysis, so you want everybody included in the end, or sometimes there's mortality, but you still want everyone included at the end. So multiple imputation is often used for that also. So the first thing we need to do, right, as we said last week, is we need to assess the level of missing data. And with multiple imputation, the variables you put in the multiple imputation method are the ones with the missing data, and you would leave variables without missing data out. So how do we find out which variables are missing data? So first we would just do a regular frequencies. So we would go to Analyze, then Descriptive Statistics and Frequencies. And then we'll leave study participant ID out of there, right? Because if that's missing, that's our fault, right? That's not the, okay. So, and we put them all in here, and we just click OK. So our first step, running frequencies. Here we go. So we see up here, there's 100 gender, 94 valid, 6 missing. Right? So basically, whenever there's a number other than 0 in the missing line, there are missing data for that variable. So there's 6 missing for the variable gender, 6 missing for income, 6 missing for age, right? And then the same for the feeling variables, right? 6, 6, 5, and 6. So we know we need to impute values for all the variables except for the ID variable. So essentially, before we do it, we should state that multiple imputation runs simulations on the missing data relative to the valid responses. So it almost makes a profile. It uses the available data to make a profile of the case with that missing data value. And then it makes several iterations where it estimates what that missing data value would be. And then it pools all those estimates to come up with a final estimate, right? So it's basically looking at the patterns of the valid responses and using those to make a probability judgment about what the missing data value would be, right, to create a full data set. So if we have a missing value for income, right, income level, it will say, what's your age, what's your gender, are you happy, right? And it will use those to estimate what your income might be. So again, there we go. So, and you can even see in the data view, right, you can see that empty cells are spotted all over here. So the first thing to acknowledge is the level of measurement of these variables. Right? So gender is dichotomous, male or female, right? 2 categories. Income is continuous. It's measured on a raw number scale. People just reported their actual dollar income. Age, of course, is continuous, right? From, say, 18, right? So that's the study criteria. It's whatever age. And all the feeling variables are rated on scales, as I said, of 1 to 5, 5 indicating the highest level of the construct, the highest level of feeling happy, or the last one, the highest level of feeling sad. Okay, so the first thing we want to do, if you recall in Missing Data 1, we talked about analyzing patterns of the missingness. It's called the MCAR and the, missing at random and not, missing not at random, right? So, but SPSS, we can use SPSS and this function tonight to actually examine the patterns of missing data rather than the bivariate analysis we did last week. So to start this, we would go to Analyze, and then down to Multiple Imputation, and then Analyze Patterns. We click that. All right. So then you'll see there's some defaults clicked: the summary of missing values, the patterns of missing values, the variables, the highest frequency of missing values. So we want to leave all those defaults clicked. And then there's also a default for the maximum number of variables displayed. So we don't need to worry about this because the default is 25. We only have 8 variables. So we're well below that. Now, the minimum percentage of missing data, right? Minimum percentage missing for a variable to be displayed. So sometimes, as we mentioned last week, people will say if you have 5% missing data, then it's not a problem. Right? So if you have 5% missing data, you don't really need to examine it. So if somebody was of that ilk, they might put 5 in this box right here. The default is 10, right? 10%. So essentially, it's the analysis. If the variable is missing 10% or less, it won't even report it as a missingness. However, as we said, it's always, well, not always, but depending on your ideology, it's almost always preferable to account for the missing data values. Right? So suppose instead of 10%, we just changed it to include all the variables with missing data. So we set it at 0.01%. And so that should include all the variables with missing data in our analysis and our imputation. So then, we have gender, right, all the way to the bottom. We have to take all our variables with missing data. Now again, if one of these variables did not have missing data, right, like if gender didn't have missing data, we wouldn't be putting it into the right-hand column. But they all do, so we are. So we put them all in the column labeled Analyze Across Variables. Right, so that's an interesting phrase, because if you look, right, so we know that there was about 6 missing data values for each variable. So when we see those frequencies, right, when the frequency said there are 6 missing data values for each variable, we don't know, right? So ID number 1, if all 6 were for ID number 1, right, 1, 2, 3, 4, 5, 6, like right across, or if they're distributed randomly, like missing here, missing there, missing there. Okay, so this is what we're saying: analyze across variables. Okay, so if we click OK, here's what we get. Okay, so it's just sometimes it takes a minute, but you can see in the lower right-hand corner it says running multiple imputation. So you know you're not just standing here for no reason at all. All right, so here we go. Is the which you can partially see now an overall summary of the missing data values. See, I told you. Percentage of missing data among all the variables entered in that analysis. So it's 100%. So each, as we saw in the frequencies, each variable has at least one missing data point. Second, it says what are the percentage of cases that have missing data? Have missing data as in have at least one missing data point. and the green signifies 43% have at least one missing data point, which is almost half. So you could see that that could indicate some real pattern of bias in, in missing data. Suppose with gender, suppose 50% of the sample are male and 50% are women. Well, if 43% of missing data, it could be all one gender. And so that could represent some bias we might like to look into. And then lastly, if you look at the values, it tells you the percentage of cells, right? The percentage of responses that are missing. So because we have 100 study participants and we have 8 variables, 8 times 100 is 800, right? So of the 800, the little green sliver is 47, right? 47 responses of the 800, which is 5.875, are missing. Right? So about almost 6%, 5.875% of cells are empty due to non-response in this case, right? Due to missing data. So if we scroll down a little, now we see variable summary. And so that's indicating that the number of missing, as we saw, the same thing with the frequencies. And the missing value patterns. So this box with the red squares will reflect if there's a pattern to the missingness. And so basically, this diagonal red line is always there. These red squares represent the missing data, right? The pattern of missing data. Now, if they're randomly strewn within, underneath this line, that indicates, randomness, or that there's no pattern to the missing data. Right? It's not biased by certain variables. If these red squares were all clustered in the upper left and clustered in the lower right, that would indicate more of a pattern of missingness. And if we go down a little, we also have, so this is descriptive, right? Have the missing value patterns, right? So the first one is the pattern of no missing data, right? So you can see the first spike, that first column that goes really high, that's the pattern where there are no missing data, and that's the most prevalent, which is preferable. However, you can also see that the little columns to the right, they're also there. So maybe there is some sort of pattern to the missingness, right, even if it's slight. So that's why it's always good to account for those missing data values. So why speculate or be unsure when you can try to account for the missing data values and have a more sophisticated view. Right, so like I said, we have about 5% of missing data. So a lot of people would say, well, 5% of missing data, they call it trimming, right? You could just trim the sample and let the 5%, the 5% just kind of fade away and not include it in the analysis. But some people, would rather account for that data. So you have to decide, what your ideology is. So our next step, right, so we go back to our SPSS, right? So we looked at our patterns, right? We looked at our graphs, right? We looked at our percentages, okay? So next, we can actually start the multiple imputation. So now we prepare the data a little. So we've seen that the pattern looks rather random, right? So that's usually the case. Usually, from my experience, when there are missing data, I don't really pick up on too many patterns within the missing data, and I look hard, right? So we're presenting tonight the most likely scenario, where you examine the missing data and it seems to be missing at random, and we'll take it from there rather than, addressing data that is not missing at random. Although that's a significant challenge in itself. So our next step, remember, we found randomness, right? So our next step is to go to the transform function, right? And then go to random number generators. Right? Does everyone have that now? So random number generators. That's our next stop. We click that. And here we go. So we have our random number generators, and we click under active generator, set active generator. Okay? Then we go down here to Mersenne Twister. Okay. We click that. Now on the right, we click set starting point, and then we'll click fixed value. All right, and then we're set with this right here. So this is our next step, right? So first, just to reiterate, first we went over, we examined the patterns of the missingness. We saw that it looked random, right? Then we went up to transform, and under random number generators, we clicked these selections. Okay, so then we click OK. Now, after that, we're ready to approach our multiple imputation technique. So if we go back to Analyze, right, it's right underneath where we were before. So Analyze, and then multiple imputation. Right? Now, before we went to Analyze patterns, but now we're going to impute missing data values. Okay, so you see? So this is how approachable the technique actually is. Okay, so now we've prepared the data, and we're actually going to approach the multiple imputation. So again, we're going to take the variables excuse me, that have missing data values, which is all of them, and we would leave any without on the left, but these will put variables in model. Right? So we put them over to the right, and then it's going to create a new data set. So we want to give it a name, and we might call it something like, new imputed data set. Would be fitting. Has to be one word. New imputed data set. All right, new imputed data set. That's fine. Now you see over here, the number of imputations is set out of default of 5. So remember when I said that there would be a number of iterations, right? A number of times that SPSS will estimate what that missing data value would be. So it's set at 5. The point of the imputation, right, is it'll estimate the value once, then it'll estimate it a second time, then a third time, then a fourth time. Now the estimates might have significant variance. So for example, did you feel happy in the last 7 days? The responses for that are 1 through 5. Right? So suppose the first iteration estimates 1, and then the second one estimates 5, then the third one estimates 2, and then 3, right? And the variance is going back and forth from all those estimates, right? So what's preferable is that the estimates, right before it's pooled, the estimates have, a small amount of variability. So, the estimate won't be jumping back and forth right before the final pooled estimate of the value. So if it takes 10 estimates to get to where the variance is being reduced, then that's what you might consider. However, normally, 5 iterations is enough. So after this, we go to method. All right, now the imputation method, right? So, right, I see up there, I clicked, so we were on variables tab, and then I clicked the tab to the right for method. Right? See, I told you I was going to try to slow it down. So, imputation method. So if we leave it at automatic, SPSS will do what we did in the table with the red squares, right? So you'll see there's two methods available. So if we click custom, you'll see that the first method is fully conditioned specification. That's the MCMC, which stands for Maricon Chain Monte Carlo method, right? Which if there's randomness, right? If there's a randomness to the missing data, that's what we'd use, right? So, and the monotone is when there's patterns to the missing data, right? So, if that's what was going on, we would use monotone. So, what's the benefit of using automatic? If we click automatic, as I said, SPSS will examine the pattern of missing data as we did initially, and will decide if the monotone method of accounting for the patterns or the MCMC method is most appropriate based on the patterns of missing data. So we're going to leave it at automatic. Now the benefit to doing custom is you can select which one if you believe you know which one is best. You could look at the maximum number of iterations, right, if you're using the MCMC. If you think there's patterns of missing data and you select monotone, you can go down here and select different methods, right, for counting for the missing data. But we're going to leave it at automatic. Okay. Now constraints. Okay, so constraints. You could imagine when SPSS estimates the missing data values, we don't want it to estimate a value that is inappropriate, for our analysis. For example, if happiness is measured on a scale of 1 to 5, we don't want the imputed value to be 5.5. Right? We don't want the imputed value to be less than 1. We want it to be between 1 and 5. So how do you make sure that happens? This is it, constraints. You're constraining the estimate. So if we click Scan Data, it's going to give us the descriptives, right, of the actual data. So up here are the variable summary, what the numbers actually are, and then down here are where we define our constraints. Right? So, for example, so you could see, right, that for feel happy, we should have gone, when you clean the data after entry, they're all supposed to be between 1 and 5, so you would have addressed any numbers that were not earlier. So 1 and 5 and 1 and 5 and 1 and 5. So then to make sure that stays that way, we go down to define constraints, and we say, okay, feel happy. So 1 is the minimum, and 5 is the maximum, right? And we would do that for each variable being estimated, as I said, to make sure we don't get a value we can't use. Okay. All right, and of course there's rounding. So if you wanted the numbers rounded, for example, if we were doing income, for example, and we didn't want any cents, we could always put in, something about the rounding. Okay, so then output. So this is where, we tell SPSS what output we want to see based on, our analysis. And by default, imputation model is clicked, and so that's good. But we also would like descriptive statistics for variables with imputed values, so we could see how the values changed with each iteration. Remember, we said we don't want it bouncing from 1 to 5 and 2 to 3 and all, things like that. So we can see how it was stable, within the iterations. And then also create the iteration history. We have to name the new data set. We might call it something like iteration 5. Okay. And OK is right. So now we click OK. And see which iteration it's currently running. So iteration 0 is the actual raw data, right? Iteration 1, right? See the lower right-hand corner? Iteration 1. Iteration 2, that's when all the values are being estimated within the different iterations. And we're going up to 5, then it's going to pool the data for us. There we go. All right, one moment. It's at the last iteration we set, and it will be giving us our output any moment now. Any moment now. There we go. And it doesn't like to rush itself. All right, there we go. All right, here we go. Now, you'll see down below here, we have several new data sets. So before we actually look at the output, let's look at the data sets. So if you look at the first untitled one, see, at first it looks like nothing has happened, but don't despair. You see over to the left where it says imputation, remember I said that 0 was when it said imputation 0, that meant that's the original data. So this is the original data. So you can see the missing values are still missing, but that's okay. If you go over to the right, you'll see right here, there's it sort of looks like a Rubik's Cube, right, for those of you from the 80s. And so it sort of looks like a Rubik's Cube. If you click on that, or if you click on the original data, you could see 1, 2, 3, 4, 5, there's the 5th iteration. So if we click on that, watch what happens. Aha. Right, so aha. So we have the actual estimated imputed values at the final iteration, 5. And you can look, see? So imputation in that column now says 5. And if you click 1, right, that's the first imputation. Okay, and then if you click 2, that's the next imputation, right? And then you click 5, and that's the final imputation, right? Now I have a treat for everybody that I didn't tell everyone about when we started. I actually had values in these cells before I deleted them. And so there were actual values that were in the cells. So then I deleted them to create missing values. And now that the software has estimated what the missing values are, we could see how well the software estimated the missing values because there were values in there. Right? So since I deleted them optimally, the software would estimate the values I deleted. See, that's why SPSS takes so long, because I play tricks on it. So, okay, the first one, 2. Right? So if we go to ID 2, this right here was 200. Well, I guess that's not so good. $280,000. That was the income. So yes, so that's not so good. And then down here, this was actually 420,000. Right? Yeah, what are you going to do? So then under gender, this missing value here for case number 9 was actually yes, 1, which means female. And then the next one down here, that actually was a male. So the software successfully estimated that that case was female and that case was male. Now the money, right, the estimations of the money, that, like I said, that wasn't so hot. But, you know. So age, right, so this missing value for age was 19. Now the age in this data set goes from 18 to 26. Right? So 21, yeah, I guess it's toward the lower bound. That's okay. This missing data value was actually 21, and the software estimated successfully 21. Now let's get to our outcome-oriented, you know, do you feel happy? So this iteration, this actually was a 3. This was a scale of 1 to 5, right? 5 being the most happy, and the actual value was a 3, which is right in the middle of the scale, and the estimate is closer to 1, which is not so happy. And then down here, actually this is not so bad. This, before I deleted it, was a 4, and they estimated 4.76. So that's closer than the first one. This value under feel good was a 2, and it estimated a 2.58, right? And then feeling strong was a 3, and it estimated 3.73. This feel glad was a 2, and it estimated 1.6. So if you round it up, that would be a 2. And finally, the feel sad, they were both 2s, and it estimated here a 2, which is pretty close. Over here it estimated a 1, which is, you know, not so close. So overall, there you see it. So you can imagine, though, you know, the more variables there are, the more data the software has to estimate those missing values, right? So the more variables and the more what? The more variables and the more study participants, right? So if there's more study participants and more variables, the software can pick up on those patterns, you know, theoretically, and make better estimates of what those missing data values are. And we have a small sample here of just 100 people and also a small amount of variables. So, you know, so we got some pretty accurate estimates, but also a few, maybe like a third, that were kind of, you know, offish, right? That we might describe as offish, right? So there we go. And if we want to do inferential analysis, right? Suppose the whole meaning of this was that we wanted to do a t-test to see if male or females have a higher rating of, you know, did you feel happy in the last 7 days? Well, now that we have our estimates in, we can actually do that t-test with complete data rather than doing the t-test and dropping the cases because there are missing data values. Right? Now, I should warn you, not all of the inferential tests are compatible with the MI, right? But a lot are. So we'll do the independent samples t-test, which is, and go to means, compare means, independent samples t-test. So our grouping variable will be gender, which is one for females, 0 for males. So we define it as 1 and 0. So it's going to tell us if male or females have a higher mean rating of did you feel happy in the last 7 days, measured on a scale of 1 to 5. So continue, and did you feel happy? We'll put it over there in the test variable, and click OK. We got to come back to that. We're running the t-test. There we go. All right, that's pretty neat, right? So you got the t-test, and then it's showing you in each iteration how the numbers were changing. So the original, right, so where there was missing values, we had 44 females and 45 males. Then you could see at the bottom, the pooled, it's 50 males and 50 females, right? So it accounted for those missing data values. So up here we see that the females' mean rating of did you feel happy in the last 7 days is, if we round up, 2.9, and the males is 2.6. Right? So that's when there's 44 females and 45 males to consider. Then down here, after all the iterations, the pooled number, which is what we would report, is 2.87. Right? So it's still just about 2.9 for females. And then for males, if you round it, it's the same, 2.6. Right? So you never know how dramatic the change might be. Right? It could have been, a big change, from 2.0 to 3.0 or 2.0 to 4.0. You never know until you actually account for the missing data and observe. Right? So here is more of a marginal change. So then if we scroll down, the same iteration pattern is also shown for our statistics. So we see in terms of significance, right? So this is if the t-test is statistically significant, the sig two-tailed. So we go to the pooled. So we see the mean difference for the original data. The mean difference, the probability level is about 0.32 if we round up, right? So it's above 0.05. So the difference between the mean scores of happiness for men and women is not statistically significant. Now sometimes it changes, right? So sometimes it's not, or it is, and then after the imputation, you get the opposite result. However, in this instance, you'll see from the pooled data, right, the significance level, I guess it's a lot closer to 0.05, but it's still, that doesn't matter because it's still above 0.05, which is, 0.99 is the same as 0.18. It's just categorically above 0.05. Right? So it's still not statistically significant. And there are other tests that you can use, like the correlation. So if we want to know if, see little swirls here, the little conch shells, it looks like that indicates that it's compatible with the MI procedure. So if we go to correlation and bivariate, and we want to know if income is correlated with those feelings variables, we could take income level, right? So does your level of feeling happy or sad go up and down significantly based on your income? Right, so we take the variables and we put them to the right. We're doing a Pearson zero-order correlation. And we click OK. See. And you will see eventually, right? There we go. And it's running the correlations. All right, here we go. So income level, right? Is it significantly correlated with, were you happy in the last 7 days? How happy? Right? So we got the asterisks all up on top here. So significant correlations between income level and all the feeling variables. But notice here the N which means how many people are in this correlation. It's 88 people, 89, 89, right? So there's 100 in the sample, so there's missing people in this test of correlation. But if we scroll down, right, so these are all our iterations. Right? Iterations, 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 down to our pooled iteration, our last, it's not a pool, the pool of all the iterations, right? So it's the average of all those iterations. So it's still significant. See, there's n is 100, right? So all the missing data values were accounted for, and the findings are still similar. And so not only is it statistically significant, but actually the value of the Pearson correlation, 0.66, 0.77, right? They're all pretty much the same. So it's still a large effect size and is still statistically significant. So it also bolsters your confidence in the findings a bit, you know, when they're indicating the same thing. So that's how we account for our missing data and how we do our inferential analysis. And if you needed to do multiple regression, right, after these bivariate tests, you wanted to do a multiple regression of, you know, all the predictors, you know, upon, say, did you feel happy? The linear regression is also compatible. Right? So we got regression and linear, see? So you have the conch shell, right? And binary logistic regression. So they're all compatible with the multiple imputation. So the SPSS knows, right? It knows that there are 5 little imputations here, and when it runs each inferential test, it's going to include, you know, inferential statistic results for each one of them. Okay, now, so that's the inferential test, but before we close our SPSS, let's look at the statistical output for the multiple imputation that we saw initially and discuss what it's telling us. Now, I saw these already. There we go. So these are more descriptives. Okay. There we go. So this is the multiple imputation descriptive output. The only reason we had to scroll up is because we did our inferential tests after this was produced. So we say automatic, the number of iterations is 5. The maximum percentage of missing values, right, 100%. Then we have little descriptives here about which had missing values and the minimum and maximum, right, and the constraints, right, what we set the constraints at. There was none for income level, and there was some for our feeling variables. So the full condition specification, right, that's all fine. Our imputation model, right, so we had 5 missing values for, you know, the last 7 days. Did I feel glad? Use the linear regression method. So it imputed 25 values because there was 5 missing, and there was 5 iterations. So 5 times 5 is 25. And then follow suit. 6 times 5 is 30. So it's just telling us how many imputations for each individual cell. And then descriptive statistics. So here's what's neat. So it'll tell you, right, we're talking about how much is the variance bouncing around from one value to the other, right? Well, here, instead of jumping back and forth, remember we showed that the 5 iterations in the data view were on top of each other. Instead of scrolling up and down, you have it right here in the descriptive statistics. So for gender, we see in the original data, right, so this was male, there was 47 males, and 1 is female, 47 females. So we look at the imputed values, and it's going and going and going. right? And then complete data after the imputation, right? So it's 49 and 51, right, which adds up to 100. So it estimated all those missing values, right? Did the same thing for income. So the original data, the imputed values, the numbers afterwards. Same thing for age. Now let's get to our happiness, because that's what I used as an example, as the jumping back and forth. All right, remember I said 1 to 5 and 2 to 3 and 2 to 4, right? So here we go. So the original data, right, the mean was 2.73 for, did you feel happy in the last 7 days on that scale of 1 to 5? So the mean is 2.73. So then you see the iterations, 2.6 and 2.9, right? So down the line, and then we get to 100, right? So those are the iterations, and then the pooled iteration, 2.73. So it's really not that different. So when we had 100, right, it wasn't really that different from the 94. Okay, so that speaks of, you know, little variance. So little variance suggests more stability. And then we have the same with all the rest of the variables. Okay, so that's it. So that's multiple imputation in SPSS. So you're much better off than where I was when I got that editor's review saying, go do multiple imputation. Okay? So I want to thank everybody for attending tonight, and I hope you got some value out of the presentation. And yeah.